Alright, sorry that this video is in 2 parts. I just momentarily ran out of space on my iPad, so we are back. Okay, and it's harder, okay? In this example here, you'll notice that the y isn't by itself already. It's not on its own side of the equal sign already. It's not isolated. Same with the x, it's not isolated. So we have to choose here, we have to choose an equation. So that's kind of our first step. Choose an equation that you think is going to be easier to isolate a variable. Choose an equation and a variable to isolate, meaning get by itself on its own side of the equal sign. So like the first one, really it's going to be a lot harder to get x by itself than it is to get y by itself, because you'd have to divide everything by 3. Same with this next one. So the y's are already just plain y's, 1y. We want to work with those. And you could pick either equation. I'm going to pick equation 2. So for me, my decisions, you can make your own, but my decision was to use number 2 and to get y by itself. Okay. So when I do this problem here, I just add 2x to both sides. And these canceled. Negative 2x plus 2x add to 0. We get y is equal to 2x plus 7. Okay. Now the y is by itself. That's what we want. We like that. So awesome. Our variable is isolated. We got that step down. Next one. Next step. Plug in isolated variable to other equation. So you don't use the same one that you just used. You plug it into the other equation. So you take this 2x plus 7, right? Y equals 2x plus 7. You take the 2x plus 7 and you plug it in for y. You find the y up here and you're going to plug in for that 2x plus 7. So for that step, see exactly what we do. 3x. We're using this equation. We already used this one. We rearranged this one. So now we're plugging into this equation. Plus, instead of y, I'm not using y anymore. I'm now using 2x plus 7 equals negative 3. If you don't understand where that 2x plus 7 is, you need to understand that. So let's take some more time to see where it comes from. That 2x plus 7 is coming from right here because we know that y is equal to 2x plus 7. We're literally taking this chunk and we're saying, boop, we're going to put it right over here. So we're getting rid of the y's, and we're putting this in place of y. We're substituting it in. Okay, then we combine like terms, 3x plus 2x. We get 5x plus 7 equals negative 3. We subtract 7. 5x is equal to negative 10. Divide by 5. We get x is equal to negative 2. This is not our answer. I don't know how many times I'm going to say that that's not our answer. Our answer is an x-y coordinate pair. We're looking at where do the graphs cross? Where do they meet? So I'm going to erase these just erase this work. So we don't just need an x. What we had here was y equals 7 plus 2x, or 2x plus 7. What we need to find a y now. So I'm going to say, well, alright, let's substitute again. Instead of x, let's plug in negative 2. We get y is equal to 7 plus 2 times negative 2. And we get 7 minus 4, right? 2 times negative 2 is negative 4, and we get 3. So we now have our y value and our x value. So we combine those together. We use both of those to get our answer of negative 2, 3. That is the answer, that is the solution to these equations. Alright, erasing this, and I'm going to give you guys one problem. Okay? If you need it, just pause the video. I think we'll probably do 2 more examples. One a little bit more complex and then one very complex. And then we should be done with substitution. Okay. All right, this is on your left-hand side. You are getting me a solution. It needs to be an x, y coordinate pair. Okay, think about what variable, whether that's x or whether that's y, what variable is easier to get by itself, and get it by itself. Okay, and then solve. All right, pause the video, do that now. All right, if you're back with me, you've already completed this, you got your solution. And we are moving on to harder ones. All right, x plus y equals 4, and negative x minus y equals 6. Okay. So what we're going to think about here is we're going to use substitution again, and we're going to think, what are we going to plug in basically? So let's figure out what variable we want to get by itself and which equation you want to use. I personally, this one looks nice because you could add x to both sides, but then you'd be stuck with this negative y. I don't like the negative y, so I'm going to pick equation 1, and I'm going to isolate my x. So in equation 1, when I want to get my x by itself, I want to subtract my y from both sides, and I get x is equal to 4 minus y, or negative y plus 4. I'll write it out the other way, because that's how we see it. 4 minus y. Perfect, good so far. We now have x by itself. We have it isolated, and we can use that to substitute. So this 4 minus y can be plugged in to equation 2. We've already used equation 1, so equation 2 for x. Okay. So we'll bring it over here. We're working with equation 2. We have negative 4 minus y. We're getting rid of the x's. Minus y equals 6. Okay? So if we have to distribute that negative, we get negative 4. Negative times a negative is a positive y. Minus y equals 6. Well, hold on. Something funky is about to happen here. Y minus y, those cancel. That's just 0. And we get negative 4 is equal to 6. Hold on. We must have done something wrong. This is weird. Negative 4 equals 6? How can that possibly ever be true? That can't be true. That's not right. So we must have made a mistake, right? Okay, well, let's think about our 3 options from last time. Here are our 3 options from last time. 1 solution. No solution. Or infinitely many. So if this is never true, like no, duh, that's not true, then can't we just say that it's no solution? Can't we just say, perfect, that's not true, no solution? And yeah, we totally can. That's exactly correct. There's no solution because that makes 0 sense at all. Which means that the lines would be parallel, right? They would never touch each other. They wouldn't cross because then it'd have a solution. They're parallel. Okay. Let's do one on your left-hand side, and then one more for me, and we'll be done. We'll make them quick, too. So left-hand side one. Negative 3x plus y equals 12. 6x minus 2y equals 18. All right, do this on your left-hand side, and then I got one more that we're going to do together. All right, if you're back with me, you've already done this on your left-hand side. We got one more to work on, and then we'll be good. We'll be done. All right. So the last one we're going to do is x minus 3y equals 6 4x minus 12y equals 24. So for this one, we're doing substitution still. We got a system because we got two linear equations. So what I'd like to figure out is which one of these do we want to use and what variable do we want to get by itself. I am telling you right now that if you look at these terms, you always want to choose the one that has a coefficient of 1. It's just plain by itself, just a plain x or plain y. That's the one you want to pick. So I'm going to pick equation 1, and I'm going to pick the variable x to get by itself. So when I take this over here, I get x minus 3y equals 6. I got to add 3y to both sides. Why? Because I'm trying to get the x by itself. Those add to 0. We get x is equal to 6 plus 3y. Perfect. The x is by itself. That's exactly what we wanted. We wanted the x to be isolated, so I could take this block, literally pick it up, and put it in for x right here. So we get 4 times 6 plus 3y minus 12y equals 24. 6 times 4 is 24. 4 times 3 is 12. Oh, looks like something funky's going to happen here too. 24 plus, let's combine like terms. So if we combine like terms, 12y minus 12y, what? That's just 0. Okay, this looks like what's happened last time. So maybe it's the same situation. We get 24 is equal to 24. Well, duh. Of course that's true. So let's think about our possible answers from last time. Our possible answers are 1 solution, no solution, or infinite solutions. Okay? Well, if this is like a duh, of course that's true. It's definitely not no solution because it's true. So it's not false, it's not no solution. It's not one solution because we couldn't find it. We couldn't find an xy coordinate. It's infinitely many because this is always true. 24 is always equal to 24. So that means the lines are right on top of each other. Right on top of each other. Alright, you got one to do on your own on the left-hand side. And then you're done. And if you finish early, just go ahead and start your homework. Just get up, grab your homework, and start that. Alright, the one you're doing, negative 2x plus 14y equals negative 28. X minus 7y equals 14. So you got equation 1, equation 2. Give me a solution. So either a coordinate pair, or no solution, or infinite. These are what the answers could look like. Alright, that's it for 11.2.